Hey, y'all, we have been talking about congruent triangles now for a little while, and we're going to start talking about what it means to be similar, and we're going to start that discussion with similar polygons. So, not just triangles, but, four-sided figures, five-sided, six, so on and so forth. So congruent means that two things are the same size and shape. Similar means that they're the same shape, but not really the same size. So if we know that two polygons are similar, we know that their corresponding angles are congruent. That's the same as when we had congruent triangles, or any congruent polygon really. The difference here is that the corresponding sides aren't going to be congruent. If they were, then they would just be congruent polygons. But we can write the ratios of their corresponding sides, and all of those ratios should be proportional. That means if I write a fraction using one pair of corresponding sides, then that fraction should reduce to the same thing as all the other fractions made by the corresponding sides. That'll make more sense when we do one. So here I have two similar polygons. This little squiggly in the middle means similar. So ABCD is similar to GHIJ. And just like when we were doing congruent triangles, the names of those polygons is so important because it tells us what pieces correspond. So the first letter A in this polygon corresponds to G, B with H, C with I, and D with J. So those tell us what angles should be congruent. A and G, B and H, C and I, D and J. So the angles are congruent. They're the same size. But you can tell just by looking at this that the polygons aren't the same size, so they can't be congruent. So if we write the ratio of the sides, so I'm going to take side AB and side GH, and I'm going to write a fraction. That fraction should be equal to all the other fractions I can write. So BC over HI, CD over IJ, and AD over GJ. If I knew how long all these sides were, and I simplified all four of these fractions, if these two polygons were in fact similar, all these fractions would reduce to be the same thing. So I just want to practice a little bit like listing the pairs of congruent angles, which I think probably will be the easier part since we've done that using congruent triangles. It's writing these extended proportions that might take a little practice. So we just look at the names and match up the letters, and those are the angles that are congruent. So R is congruent to D, S is congruent to E, T is congruent to F, and V is congruent to G. And it's all about the order, it's all about the name. And then I just put the sides that go together. I like to just put the sides from the left figure on top of the fraction. It's not wrong to do it the other way, but I like to be consistent. So I just put this polygon's name is first, so I'm going to put the sides from this polygon on top of the fraction. So RS goes with DE, and ST goes with EF, and TV goes with FG, and RV goes with DG. And so again, all of those fractions, if we knew how long the sides were, would reduce to be the same value. It's similar or the same thing if we have triangles. Again, we just match the letters up to find the angles. And then we match the letters up again to put the sides together, but they're not congruent. They make fractions. So CA goes with WV, and AB goes with VT, and CB goes with WT. And again, these fractions, if we knew how long the sides were, would simplify or reduce to be the same fraction. Oh, I'm sort of giving it away down here. So I want you to, even though I sort of gave away a little bit of the answer there, I want you to put the corresponding angles together, the congruent angles, and also write the extended proportion. So pause, do that and then come back and check your answer. So as I kind of gave away when I moved that that shield, here's my angles. Again, I'm just looking at the order of the letters. And then I have this nice long extended proportion. I have two pentagons with 5 sides, so I'm going to have 5 ratios that are all proportional. And if I knew how long they were, all 5 of these fractions would simplify or reduce to be the same value. So that value, that fraction that all the ratios simplify to is what we call a scale factor. It relates one polygon to the other. And so I know that these two polygons are similar because I have this similarity statement up here. And so now I know how long all the sides are. And I know that those are all the sides that correspond. So this is the extended ratio. I'm going to plug all the side lengths in. So HD is 24, RP is 16, DE is 18, PL is 12, so on and so forth. So now I actually have values in my extended ratio. And then I want to simplify each of these fractions as far as I can go. So 24 over 16 can divide by 8 and become 3 over 2. 18 over 12 divided by 6 becomes 3 over 2. 12 over 8 becomes 3 over 2. 24 over 16 is 3 over 2. All these ratios reduce to the same fraction, and that fraction 3 over 2 is what we call the scale factor. And so to be specific, this is the scale factor from the large polygon to the small polygon. Sometimes you might be specifically asked, what's the scale factor from the small to the large? And all that would be this fraction flipped, so 2 over 3. Sometimes we write these things a little bit differently. We can write it as 3:2, or small to big, same idea. So let's do a couple. We want to figure out if these things are, if these triangles are similar. And we have to examine both the angles and the sides. So in these two triangles, since all of these angles have one arc in them, that means they're all the same in both triangles. So we have congruent angle pairs. And then we write the ratio of corresponding sides. I really don't know which sides go together because I don't know the names of these triangles. But all of these sides are 9 and all of these sides are 15. So all of my ratios are going to be equal, and they're all going to reduce to 3/5. And so these two triangles are similar, and the scale factor from the small to the large triangle is 3 over 5. Let's look at these two rectangles. Again, the angles, they're all right angles in both figures, so all the corresponding angles are going to end up being congruent. And so that's step 1 to them being similar. And so now we need our sides to be proportional. These are rectangles, so I didn't label all the sides, but that one would be 12, and that would be 10, and 8, and 9. So again, I don't know which side technically goes with the other ones, but if it's going to be similar, that my larger side in this larger figure should go with the larger side in the smaller figure, so 12 over 9 and 10 over 8. And those two fractions are not going to simplify to be the same thing. This would be 4 over 3. This would be 5 over 4. So these are not similar polygons. In this one, if I examine the angles, so I'm just given these two angles, I would always solve for the third one. And you can see that I don't have congruent pairs of angles in these two triangles, so I don't even need to examine the sides. If they don't have the same angle measures, they're not going to be similar, and so these two triangles are not similar. And since I'm giving away the answer again, we'll go over this last one together. I have to examine the angles before I can do this work over here. I have a right angle in each, I have a 1 arc angle in each, and I have a 2 arc angle in each. And so all my corresponding angles are congruent. And then I match up small side here with the small side here, middle side with middle side, large side with large side, so hypotenuse with hypotenuse. I write my fractions. I wrote them from the larger to the smaller. They all reduce to 2 over 1. So they're similar, and the scale factor is 2 over 1. If you wrote the scale factor from small to big, it would be 1 over 2. They'd still be similar, and that would be the scale factor. So that's all I have for you. Make sure that you write down any questions you have so that you can ask me when you get to class. So when I say, hey, do you have any concerns with the lesson? You make sure that you know what things bothered you about it and what help you need.